Okay, so I am going to be taking you through the entire syllabus of the 10th grade chemistry for the ICSE board examination. We have 4 study of compounds. I'll be beginning with the first one. This is a really easy topic. I'm going to be making markings throughout. You can study the entire chapter with me. It's not much to do. We'll finish it off really quickly. There's not much to do in it. You just need to understand it. There are some application questions. You need to know some preparations. And once we're done getting through the whole chapter, we'll also once just refer to the Icse syllabus and we'll just go through a quick revision. I'll also be putting out notes for the same chapter tests, combined chapter tests, as well as preliminary tests. Now to begin with, we all know that the molecular formula of hydrogen chloride is HCl. So this is the first thing that we need to mark. The molecular formula of HCl. Just give me a minute. This is not working. Yeah. This is the first thing. So we need to know the molecular formula. You got to know the molecular mass. Now, we know that HCl has a covalent bond. They can ask you why. So why does it have a covalent bond? What is a covalent bond? So an ionic bond is when you have ionic is when you have a metal and a non-metal, whereas a covalent is mutually sharing of electrons, whereas ionic has donate or accept electrons. So this, in better words, you can say it is transfer of electrons, whereas in covalent, you have a mutual sharing, as we can say that hydrogen. Now, in order to attain stability, hydrogen requires 2 electrons, whereas chlorine requires 8 electrons. Hydrogen has 1 electron, chlorine has 7 electrons. So this electron of chlorine and this electron of hydrogen mutually get shared in such a way that hydrogen has 2 electrons and chlorine has 8 electrons. So in this is, you need to know the dot structure as well as the HCl. There'll be more elaboration of this in the topic of chemical bonding, where we'll actually learn dot diagrams. And orbital diagrams we already know. Now, occurrence is not that important. We could just say you can read this. What we need to know is that muriatic acid is another name for hydrochloric acid. Sorry. Now, again, it occurs in free state, in volcanic emissions. It's present in gastric juice of mammals, helps in digestion. This is just a read. It's not very important. Okay? Now, general preparations of hydrogen. This topic is very important. The first thing we're going to look at is biosynthesis, that is direct combination. So in this you have hydrogen, H2 gas plus Cl2 gas in the presence of diffused sunlight is 2HCl gas. Here you have to remember to write the condition. So condition of direct preparation is diffuse sunlight, and you have to remember your balancing. If you do not balance in chemistry, you will either get 1 for an equation or you'll get 0. If you do not balance an equation, you will get a straight 0. Now, why they can ask you, why is diffuse sunlight required and not direct? So this is a give reason, not a very important one, but we can just go through it. Because the reaction is explosive in direct sunlight, but it is negligible in the dark. So we use diffuse sunlight. However, in the presence of a catalyst such as activated carbon, the reaction takes place even in the presence of dark. So you can just go through this. Now, this was the first preparation using diffuse sunlight. We're looking at synthesis by direct combination. First one, we had moist hydrogen with chlorine. Again, moist is a keyword. In the presence of diffused sunlight, The second is a burning jet of hydrogen burns with chlorine, forming hydrogen chloride. Equation will be the same, just there's a burning jet of hydrogen. Now we have our second general preparation method, that is our heating of metallic chloride. So if you take a metal chloride, say NaCl, plus sulfuric acid concentrated, you have to mention concentrated. You have to mention your condition, which is below 200 degrees Celsius, you'll get NaHSO4 plus HCl. And if you go above 200 degrees Celsius, you'll get Na2SO4 plus 2HCl. So this is, you'll be getting a bisulfate. Here, you'll be getting a sulfate, a metal sulfate. Again, balancing is important. Temperatures you cannot miss, as if the temperature is below 200, you get a bisulfate. If it's above 200, you get a sulfate. The next equation is with copper chloride. So copper chloride with hydrogen, with sulfuric acid in the presence of heat will give you CuSO4 plus HCl. Again, your balancing is important. So now to summarize up till here, we first learned the molecular formula, molecular mass, covalent bond. Why it's covalent? Because it's a mutual sharing. We've learned the difference between ionic and covalent, which will be further elaborated in the chemical bonding chapter as well. We know that you have to learn the diagrams. We've learned the other name for hydrochloric acid, that is muriatic acid. We know that the occurrences are not very important. There are two preparations by synthesis. One is your moist hydrogen with chlorine in the presence of diffused sunlight. Second is a burning jet of hydrogen in the presence of chlorine. Third, we learned the next method, that is by heating with a metal chloride and concentrated sulfuric acid. Here we have a metal chloride. If you're using NaCl, you have to specify the temperature. If it's below 200 degrees Celsius, you will be getting a bisulfate. If it's above 200 degrees Celsius, you will be getting a sulfate. Again, you have to balance your equations, and that's very important. Below H2SO4, you have to write that it is concentrated. Now let's move on to the next important topic, that is laboratory preparation of hydrogen gas. This can be prepared by the action of concentrated sulfuric acid with sodium chloride. Okay, so this preparation has been broken down into a number of subtopics. We will be studying the reactants, the procedure, the reaction, the purification. There are one or two give reasons that come with this. We will be learning the collection method. How do you identify whether what is evolved is hydrogen chloride, and the precautions. So just go with me and we'll be finishing the preparation quickly. So first we know that the reactants are sodium chloride and concentrated sulfuric acid. Concentrated is important. Now, this is your laboratory setup. They can give you the diagram and they can give you this for marking purposes. They can ask you to label the diagram. So this again is very important. So in this beaker, we are heating, this is sodium chloride, okay? We're heating it and we're passing the flames through this tube into another tube, which is full into another beaker, which is filled with concentrated H2SO4. So our first step is, and so what you're doing is, you're pipetting in concentrated H2SO4 and you're heating it, and you're passing the fumes through concentrated H2SO4 again. And whatever you're getting, the gas that's evolved, then passes through this and gets collected in a beaker. This beaker is empty. So let's first study it and then we'll understand it. So just get the diagram in your head first. That is, you heat a flask which has sodium chloride in it. You're pipetting concentrated sulfuric acid. This gets passed through another container having concentrated sulfuric acid. This has one more tube connected to it, which takes your air into your last beaker where your hydrogen chloride gets collected. Dry hydrogen chloride. So let's read it. Place some common salt in a flask and pour concentrated sulfuric acid through the thistle funnel. Thistle funnel, the reaction proceeds slowly in the cold. On heating the mixture gently, there is effervescence and HCl gases evolved in a controlled manner. So this is the same thing. What is this? This is your NaCl and H2SO4 concentrated being heated, and you'll get an effervescence. The gas is dried by passing washer bottle containing concentrated sulfuric acid. So they can ask you, if you're anyways putting in concentrated sulfuric acid, what is the need for this? What is the need? We know that concentrated sulfuric acid is a dehydrating agent. So when you pass the gas through it, the gas dries up. So that is very important. We need to know this. This is a very important give reason which can come for 1 mark. This is your give reason. Water is collected, HCl is collected by upward displacement of air in a glass jar. Now, how it is collected by upward displacement, we'll see. But we know that in this, what they're saying is that when hydrogen chloride goes in, hydrogen chloride gets collected here and air gets collected on top. That is, the air gets displaced upward. Now, what is the reaction? We studied both the reactions. We know that NaCl plus H2SO4 below 200 degrees Celsius gives us NaHSO4 and HCl gas. This sign symbolizes your gas. Though it is reversible, yet it goes to completion as hydrogen chloride continuously escapes as a gas. The reaction can occur up to the stage of formation of sodium sulfate on heating above 200 degrees. So you begin with this, but you can go above to this. Both these reactions are super important. Now, why do we use these particular, this is another important to give reason. Why are these reactants preferred? So you can say sodium chloride is preferred as it is cheap, and therefore it is preferred for preparation over other metal chlorides. And concentrated nitric acid is preferred as concentrated nitric acid is not used. What do we prefer? We prefer concentrated sulfuric acid, because concentrated nitric acid is volatile and may volatilize out along with hydrogen chloride. So this is a very important give reason. Next, we come to purification of HCl. First, HCl is dried by using concentrated sulfuric acid. We have already studied this, as this is your dehydrating agent. The other drying agents like phosphorus pentoxide and quicklime cannot be used, since, again, this is your important to give reason. These are important reactions. These you need to use in order to support your answer. So they can ask you, why do we use concentrated sulfuric acid as a drying agent, and why do we avoid using P2O5 and CaO? This is because they react with hydrogen chloride. So P2O5 plus HCl gives POCl3. So you have P2O5 and you have HCl. So first you have a P, an O, and a Cl3. When you balance it, it will give you a POCl3 plus 3HPO3. And your CaO plus HCl, this is your basic reaction. This reaction is a little, first reaction is tricky to learn. Second reaction is a basic reaction. Now, how is it collected? We already learned that hydrogen gas is collected by the downward delivery. That is upward displacement of air. We'll focus on the word upward. When they ask us how is it collected, we'll focus on the words upward displacement of air. Why is it collected by upward displacement and not downward displacement? As it is 1.28 times heavier than air. Since it is heavier, it will go down, correct? If it was lighter, it would stay up, but it's heavier, so it will go down, and air being lighter will get displaced up. Why is it not collected over water? Again, an important reason, since it is highly soluble in water. Okay, so we know hydrogen chloride gas is collected by upward displacement of air, as it is 1.28 times heavier than air. It is not collected over water since it is highly soluble in water. Now we need to know the identification. When the jar is completely filled with hydrogen chloride, fumes appear above the jar's mouth. So this is the effervescence that we were talking about. Okay, so this is your observation. We have to give this observation. What will we say? When hydrogen chloride gas is exposed to air, it gives white fumes due to formation of hydrochloric acid on reacting with atmospheric water vapor. So what is the reaction? What is the observation? Immediate observation is you will see white fumes as it reacts with the atmospheric water vapor. Now, how do you know what is the test? This is the test. This will be used in your practical chemistry. It will be used in your analytical chemistry. And there will be a number of application questions on this. Now, HCl plus NH4OH gives NH4Cl plus H2O. And we know NH4OH is actually going to give us dense white fumes. So, in order to know whether a glass jar is full, bring a rod dipped in ammonium hydroxide near its mouth. This is your test. And when you do, dense white fumes of ammonium chloride will be produced, providing thereby that the jar is full of hydrogen chloride gas. So what is your test? Our test is that when a glass rod dipped in ammonium chloride is brought near the mouth of a gas jar full of HCl, we observe dense white fumes of ammonium chloride. Okay? Thereby, the jar is full of a hydrogen chloride gas. This is your proof. Next, what are the precautions? Again, precautions are very important. You will have precautions in each compound study. In each compound study, some of the precautions may overlap, but you need to know the precautions. So the lower end of the thistle funnel must be dipped in concentrated sulfuric acid. This must be dipped inside. If it is not, then the gas won't really reach down. It will just escape out. Next, delivery tube should be dipped in drying agent, concentrated H2SO4. Because again, if it's not dipped in, it will escape out. So your first thing is that your thistle funnel should be dipped inside the concentrated acid. Your second point is the delivery tube should be dipped inside your drying agent, concentrated H2SO4. And your third point is temperature must be maintained at nearly 200 degrees Celsius. This was a brief overview of your entire laboratory preparation of hydrogen chloride gas. At the end of the chapter, we will go through a revision, a quick 10-minute run through of the whole chapter. Now, we are coming to the reason why the temperature above 200 degrees Celsius is not apt. It's not apt. Because at higher temperature, the glass apparatus may crack, fuel is wasted, and sodium sulfate forms a hard crust which sticks to the glass and is difficult to remove. So we have glass may crack due to the heat, fuel is wasted, and the sodium sulfate forms a hard crust which gets difficult to remove. So these three give reasons are again super important. Let's now move on to the physical properties of hydrogen chloride gas. It is a colorless gas. It has a pungent choking smell. So when you're giving your observation or your test, when you're giving your observation or your test for hydrogen chloride gas, you have to mention its scent. You will say a colorless, pungent, choking smelling gas is observed, which gives dense white fumes with a glass rod dipped in HCl. And you can also mention its acidic nature. That is, it will turn blue litmus red, which we'll come across later. So we need to know that it's acidic or sour. It is corrosive in nature. we did this, that it is 1.28 times heavier than air. Boiling point, melting point, they won't ask you the values. They won't ask you the values, so not needed. When subjected to high pressure, okay, wait, look, this is also not important. Solubility. Hydrogen chloride gas is highly soluble in water. We just need to know this. And this is why it is not collected over water. This is why it is not collected over water. Clear? We can also say hydrogen chloride, being polar covalent, is soluble in organic or non-polar substances such as acetylene and toluene. So you can know this again, not important. Now, to show, now we're going to do an experiment. We're going to do two experiments to show that hydrogen chloride gas is heavier than air. Our first experiment is we're going to take a candle in a jar and we have another jar of HCl. Now we know that the candle is lighting, but as soon as we put the HCl jar, tilt it over this, the HCl, being heavier than air, will take up the place of air and the air will be forced to rush out. Thus, the candle will burn out. So let's just read it. Can be proved by pouring the gas of a jar with a burning candle. The candle gets extinguished. This you need to know. Because hydrogen chloride gas, being heavier, occupies the lower portion of the jar and forces the air out of it. Now, your next experiment is to demonstrate the solubility. The previous experiment was to demonstrate that hydrogen chloride gas is heavier than air. Now we're going to demonstrate the solubility of hydrogen chloride gas. This is the fountain experiment. It is a very important experiment. This chapter of hydrogen chloride gas is very important in our syllabus. So now we'll begin. So this is the setup. You have blue litmus solution. You have HCl gas in this beaker out here, this HCl gas. And you have a jet tube. This is your dropper. So what we do is, we take a dry round bottom flask with dry HCl gas, arrange the apparatus as shown. On the mouth of the flask, we have a rubber, this is our rubber stopper. Okay, this is our rubber stopper. Now, through one hole, pass a long jet tube, and through the other hole, pass a dropper with a few drops of water. Okay, so this is our dropper, and this is our jet. Put the jet tube in the beaker containing blue litmus solution. Press the dropper. It is seen that the blue litmus solution enters the jet tube with a great force, forming a red fountain. What does this show us? As the water goes in the flask from the dropper, HCl gas present in the flask dissolves due to high solubility, therefore lowering the pressure inside. Now here we have only gas. When this water goes, it gets dissolved in the water, your HCl gas. So the pressure decreases, correct? Now if the pressure decreases, we learned in physics, the pressure here decreases, the blue litmus solution will be forced up. We also know that the blue litmus solution turns red. This shows us the acidic nature. So they can ask you that the fountain experiment is actually used to show us two things. The first thing is that it is used to prove solubility, and it is used to prove acidic nature as well. Okay. Now moving on. Chemical properties. Combustibility. The gas is neither combustible nor a supporter of combustion. As seen here, it did not support the candle from burning. It immediately extinguished the candle. It does not burn, rather it extinguishes a burning splint. So this is important. Hydrogen chloride gas is neither combustible nor a supporter of combustion. Next, we'll be looking at thermal dissociation. On heating, so this is again reversible. As we have H2 plus Cl2 gives us HCl. but the conditions are different. So it's not irreversible. Thermal dissociation means that a compound breaks down into its constituent compounds in the presence of heat. That's where it gets thermal from. So when you heat it above 500 degrees Celsius, again, condition is important. It dissociates into hydrogen and hydrogen chloride. You have to know the equations of hydrogen chloride with all metals. Metals that come before hydrogen in the electrochemical series form their corresponding chlorides. So all the metals, so you've learned the electrochemical series. If you haven't, I'll be uploading a electrochemical series tutorial, a quick 10-minute one to give you the basis of how it works so that you find it easier to form equations later. We'll have an equation class where we'll do all the 100 equations of the entire syllabus. So please stay tuned. Now, anything with any metal with hydrogen chloride will give us the metal chloride and hydrogen gas. You have to just, so you know how to form a compound. Say Na has a valency of +1, Cl has -1. So when they combine, they form NaCl. Whereas if you look at FeCl2, we have Fe2 plus and Cl minus. Thus when they combine, they form Fe plus Cl2. And all of these give us H2. This again is a proof of acidic nature. Acidic nature. Now, reaction with ammonia, important mention in the syllabus. It combines with ammonia to form dense white fumes of ammonium chloride. This is what we had learned, and this is going to form the basis of your chapter, of everything ahead, of how you form your observations. You need to understand what combines with what to give us what observation. And these are the only two gases in your syllabus that combine to form a solid. So the question can come like, name two gases that combine to form a solid, and you have to mention NH4Cl. Next, hydrochloric acid. When hydrogen chloride gas is dissolved in water, hydrochloric acid is formed. The covalent compound ionizes in water due to its polar nature. Again, this equation is important. Now, liquefied hydrogen gas does not conduct electricity. It shows this is important. Actually, this is not very important. Let's not focus on this much. The gas is soluble in toluene, that is organic polar solvent. We already learned this. And now we will directly go to the laboratory method of preparation of hydrogen chloride. The one that so we are going to prepare it using hydrogen chloride gas in water. So this is the setup. Again, setup is important. An inverted funnel connected to a hydrogen chloride supply is placed in a beaker in such a way. So we are forming, preparation of hydrochloric acid in such a way that, just give me a minute. In such a way that it touches the water taken in through. So only if this touches the water will the hydrogen chloride directly enter. Else it will escape out. See, in this case, there's an escape. So this is a wrong diagram. And this is what we have to follow. Now why? Since hydrogen chloride gas is highly soluble in water, the water rises up the funnel, back suction occurs, and in turn the level outside the funnel falls. So what we're saying is this is a continuation of the diagram. So when we have this and the hydrogen chloride gas enters, the hydrochloric acid enters due to the pressure, it will get lifted up as a pressure difference is created, and this air gap will be formed. However,